Now, all credit goes to these people. First of all credit goes to these people over here. Second of all, we're moving. Now we can move on, right? So last time we finished up with this portion over here, which is 24, which is a beautiful equation. Now we need to use 22 over here with the last relationship to get everything, which we did. Pretty sure we did, but I'll redo it. And then what's the last thing to do? Together with this one next, we'll give you this equation, okay? Reference x plus no, 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 no. Okay. I think we're good. I think we get it. I think we can do it. Okay, I'll just a simple form. Okay, we can do this. All right. So let's start with our. I don't remember where we left off, so we'll just start from the beginning again, really quickly. We'll use our knowledge of the Navier-Stokes equation, and this time we'll go a little bit fast by skipping the derivative over here, which obviously is going to index notation, but we're not doing that right now. We're just going fast. Uh, density equals 0, and with this you can notify that density. Oh, my apologies. And now we know that if we divulge this, we know it's going to be pi over there plus ui over here, density pi, density x plus ui, density u, pi dx equals 0. Now we got that. Oh, you see, repetition makes you memorize. It's a fact. And sorry. I think I got it right, hopefully. If I didn't get it right, then we're in problematic situation now. Yes, we got it right. Next would be our information about, I believe, our momentum equation, right? Which is going to be density, V, and we're using Euler, right? If you don't remember, I have to double check. V dot gradient V equal negative gradient P, which equals gradient V. Oh, it has to be one high Reynolds number. Get rid of that. Plus V dot gradient V equal negative 1 divided by density gradient P. With that said, we have our V over here, V dt. So we can do gradient V pi dt plus V, which is going to be U. This is going to be U too. And then it's going to be density V pi over density X plus 1 divided by density gradient P gradient X with the delta and the delta. I think it's an I over here, if I remember correctly. Let me double check, but I'm pretty sure it's I. Yeah, because Taylor series. Okay. All right. We got all that. You see? Repetition. I love repetition. It does A equal. Oh, no, we're not. We're too fast. We're too fast. This is what pride gets you. I'm joking. Uh, we already talked about what this does. With Taylor series again, with ln, we get pi over p, I believe. Oh no, I think we got p pi over pi equal alpha density pi divided by density I. Okay, and then this gives you later on pi equal I squared, and then density pi. Okay, now first thing we do is stick it into here, right? We get things out, and you see that a is constant. It has to be the perturbation because it's average. It has to be constant. Now I don't have it fully memorized, so I'm gonna be looking back on up, but I'll try my best to not look at that. So we know that density pi equal p pi over a squared, right? Ai squared. So it's a p pi dt, and then d over here 1 divided by ai squared plus I believe this was density, so it has a I believe another density equation. So density pi 1 divided by ai squared. Know that. Eraser. Dx, I believe, plus, oh, there's a u over here too, ui, I think. Let me just double check. Yeah, ui. Okay, there's a square there too. And after that, it is density ui, because that form doesn't have any changes, and it has dx, and I believe it's pressure, but we're going to keep it pressure for some reason. Do I know why? No. Do I want to know why? Yes. And I know why, actually. It's because of the propagation, right? What I'm trying to say is that they want to know the propagation of pressure, because pressure is what makes everything move beautifully. Anyways, P Anyway, there we go. That is the form we want. Unless I forgot something. No, this is supposed to be this. Yes. And that. Oh no, I'm forgetting something. What am I forgetting? AI square. Oh, I made a mistake. I made multiple mistakes and no one catched it because I'm alone. Over here is supposed to be density. It's supposed to be density AI squared because it's moved in and then cancels out. And that should be the final form of that, if I remember correctly. Yeah, we did it. Now, I know it's a little messy. I should really be more in control of my life, but right now, yeah. I am in control. Anyway, I think hopefully I am. Anyways, next up we have our this equation. Now we have to figure out how to get this equation over here. You have to uh, add x prime oh, dt. And here's the important part. You have to add a u prime x comma t dx prime. Now what this does is momentarily shift everything off of its axis. But this, notice here that will cancel out with a negative ui, because we already discussed that this portion over here is ui. So this equals delta u prime x prime comma t parentheses dt equal ui delta u prime x comma t parentheses x prime. Beautiful. The reason I got confused in the beginning is because I didn't show everything. Now I show everything, it makes sense. So show everything is what my brain is saying. Because that's what transformation means. Yeah, am I finished now? Is there next, what is next anyways? Next up is this equation, looks like. And we're momentarily shifting that to a shifting it backwards. Now, look at these partials. Now, you want to get rid of this middle portion, right? It's the exact same way, exact same. So mark my word, I need to remember how to do this more confidently because this is going to be important. Let me see how this works. We already have this form. So what this needs to be written as, which is the delta p x comma t. And this will equal delta p prime x prime t delta t plus u I delta p delta x prime. Yes, this is absolutely necessary. What this allows you to do is if you go up over to, I'll just write the original equation down over here. Delta p prime delta t plus ui delta u prime delta. Have the equations for that. Change the cross differential, for example, take the time derivative and add delta I times. Okay, never heard of this. Now we're gonna add another derivative and say delta t delta t. So we can erase that and put delta. So we're gonna do, come on, work. Now we're gonna do delta I a squared I, and then we're gonna do delta x delta t u. Now delta tu, remember we have an equation for that earlier over here.